Today's lesson is on similar solids. So let's just start by understanding what similar solids are. They're solids, they're very close to similar figures, the other similar figures that we've talked about through the year, similar polygons, similar triangles. They're solids that have exactly the same shape, but not the same size. All right, just what we remember of similar solids. And we know then that two solids will be similar if the ratio of their corresponding linear measurements are proportional. Okay, so what are the linear measurements when we're talking about solids? Well, we got the height, we got the radius, what else? We got length, width, and we got slant height, remember? Our old friend L when we're talking about pyramids and cones. So those are our linear measurements. So if those are proportional for the corresponding parts of the solids, then we know that we do have similar solids. So let's take a look at some and see if we can decide whether they're similar or not. It says, okay, are these similar? If yes, give the scale factor. All right, so we want to pick a corresponding part. So I think I'll pick the height here. The height is 12 here and 3 here. So if I put the ratio here, I've got 12 to 3, which is 4 to 1, right? So my scale factor of heights is 4 to 1. So if I look at corresponding sides, does that equal this one to this one? And though I don't mean those to be congruence marks, I'm just marking them so I know which sides I'm comparing. So does that equal 8 to 2, and does that equal 20 to 5? And if all those are equal, then they are similar. And yes, indeed, all of those are 4 over 1. Or remember, you can also write your scale factor this way. So yes, for sure, these are similar. All right, how about these two rectangular prisms, or I guess we could call, well, square prism? No, these are rectangular prisms. I do have square bases. They're not cubes for sure, though. All right, so let's pick some corresponding parts. I'll pick this one and this one. So I've got 6 over 10. If I simplify that, that'll be 3/5. And then if I look at this side and its corresponding side, that's 6 over 10, so I know that also equals 3/5. And if I now take this and this, the heights of both of my prisms, I have 8 over 12, and the question is, does that equal 3/5? That is 2/3, so whoops, all the corresponding parts are not proportional, so no, these two prisms would not be similar. So guys, when you're trying to decide if your solids are similar, you need to compare all the corresponding parts. Okay, oh, we got another set. We got some cylinders here. So let's take the radii. Got to be careful here because I'm given the diameter, so I got to realize here that the radius is going to be 12 inches. So let's compare the radii, write the ratio. So I've got 12 over 10. If I simplify that to, that's going to be 6/5. And the height of both my cylinders, I got 30 and 25, so hopefully that equals 6/5. 5 will go into that, 6 and 5. So yes, indeed, those corresponding linear measurements of the cylinders are proportional. So therefore, those two cylinders are similar. All right, how do I compare volume and surface area? Okay, we haven't, well, yeah, I guess we did talk about volume last time. So if two solids are similar with a scale factor of A to B, or remember, we can also write it this way, then their surface area has a scale factor of, just like we learned in the last unit, a squared to b squared, right? A squared to b squared, or a squared to b squared, like that. And as you could probably guess, if I asked you to, the volume, the ratio of the volumes is a cubed to b cubed, or a cubed to b cubed, like so. All right, so let's see what we got here. Some examples. Identify the scale factors for each pair of similar solids. Okay, so we want to do the scale factors, we want to do the ratio of the areas, and we also want to do the ratio of the volumes. So they're telling us that they're similar, so we don't have to check all of our corresponding linear measurements. So let's just pick one. Let's take this one right here. Let's take 6 and 3. So if we write the ratio of these two corresponding linear measurements, we know that's 2 to 1, right? Those are the linear measurements, okay? So if I'm going to do the ratio of areas, I know that's going to be 2 squared to 1 squared, which is 4 to 1. And if I do the volumes, I know that's going to be 2 cubed to 1 cubed, which is 8 to 1. Alrighty, let's look at the cones. Let's take the radii, since we have the radii of both the bases. So the ratio of our radii is 4 to 6, which is 2/3. And now we want to find the ratio of the areas. So A1 to A2 will be 2 squared to 3 squared, which is 4/9. The ratio of the volumes will be, I have to go all the way back to the scale factor, 2 cubed to 3 cubed, and that's going to be 8/27. All right, let's see what we have next. How do I solve problems? All right. Well, let's solve a few problems then. When given information about the volume of surface area of solids, you always want to find the scale factor first. So in other words, if I'm given the ratio of the surface areas, I got to go back and find out what the scale factor of the solids is before I could find the ratio of the volumes. So always find the scale factor of the linear measurements always do that first. Find the scale factor, ratio of linear measurements. All right, so let's see what we got here. We have these triangular pyramids. We know the surface area of the first is 25 square feet. Surface area of the smaller is 4 square feet. So I'm going to find the ratio of these areas. It's 25 to 4. So that's A1 to A2. All right, but I want the scale factor, so I'm going to just call that S1 to S2. How do I get that? Well, I got to take the square root of the areas. So that's going to be the square root of 25 over the square root of 4. So the scale factor, which I always need to find first, is 5 to 2. Right? It's 5 to 2. So now, let's see, what did it at? Oh, we got to find, I guess we just need to find the ratio of the volumes. So if I want to find the ratio of the volumes, then I have to cube the numbers in my scale factor. So that's going to be 5 cubed divided by 2 cubed, which is 125 to 8. Okay. All right, let's look at these rectangular prisms that we have here. We're given the volume. So if we do the ratio of volumes, we have 162 to 384. So I want to find the scale factor of the solids. So if I want to find the scale factor, what do I have to do? I have to take the cube root of the volumes. The cube root of 384. So, what I need to do is think of the largest perfect cube that is in both of these. Let's see, the cube root 27, I believe, goes into 162 6 times, right? I believe that's correct. And 27 goes into 384, yeah, 27 into 384. 64, that's a perfect cube. 64 times 6. So not 27. 27 is not my perfect cube in 384. And then, remember, I can take the cube root of 27. That gives me 3. Got the cube root of 6 left. Down here, the cube root of 64 is 4. I've got the cube root of 6 left. So my scale factor, I got to come up. My scale factor is going to be 3 to 4. All right, so that's my scale factor. So if I want to know the ratio of areas, A1 to A2, what am I going to have to do? I have to square those numbers in my scale factor. So that'll be 3 squared to 4 squared, which is 9/16. All right, solid A and solid B are similar. The ratio of the height of solid A, so I've got the scale factor since I'm talking about the linear measurement. So A to B, let me stick with it. Well, yeah, we'll do it that way. The ratio of the height of solid A to the height of B is 7 to 3. Find the ratio of the volume. All right, well, I don't need to find the ratio of the surface areas to find the ratio of the volumes. I can just come right in here and say, okay, if that's the scale factor, then the ratio of the volumes is 7 cubed to 3 cubed. And 7 cubed is 343, I believe. And 3 cubed, of course, is 27. All right, so you just got to remember, find the scale factor. Then if you want the ratio of surface areas, you square that. If you want the ratio of volumes, you cube that. So we got cones. Cone A and cone B are similar. The ratio of the surface area, so I got surface area. Surface area of A to the surface area of B is 16 to 1. Find the ratio of the radius. Okay, the ratio of the linear measurements is also going to be the scale factor because the radius is a linear measurement. So if I want to find the scale factor, so let's just call it the side length or the radius length. I can call it R, I guess, since we're talking about radius. So the radius of cone A to the radius of cone B will just be the square root of 16 over the square root of 1, which will give me 4 to 1. And that's the ratio of the radii. That is also the scale factor of the two similar cones. All right, we got a couple more, and then we'll be finished. So you know what? It would be a good idea here for you to pause the video, work these two problems, and then come back and check to make sure you know what's happening here. Cylinder A is similar to cylinder B. If cylinder A has a radius of 12 feet, all right, so we're looking at scale factor, linear measurement. So I'm gonna use S for scale factor or side length. So side length of A divided by the side length of cylinder B is 12 to 30. I'm going to simplify that. 6 goes into 12, 2, 6 goes into 35. So there's my scale factor, 2/5. Uh-oh, I almost made a mistake. Look what I did. In cylinder B, we're given the diameter. Whoops, better go back, because if I'm going to use the radius of one, I got to use the radius of the other. Cylinder A has a radius of 12. I got to use the radius of cylinder B, so that would be 15. I almost got caught in that trap. All right, now, so what is my scale factor? 3 goes into 12, 4, so 4/5. 4/5 is my scale factor. So now to find the ratio of the volumes, volume A to volume B, it's going to be 4 cubed over 5 cubed. So that's going to be 64 to 125. And one more, Pyramid A is similar to Pyramid B. Pyramid A has a volume of 648, so we're doing volume, ratio of volumes. That's 648. B has a volume of 1029. What is the ratio of the surface area? All right, I can't find the ratio of the surface areas until I find the scale factor. So I want to find the scale factor of the ratio of the sides, or a linear measurement. So I'm once again going to use S for that. I know I got to take the cube root of 648, and I got to take the cube root of 1029. And if I simplify that, I end up with 6 times the cube root of 3 to 7 times the cube root of 3. Those two cube roots of 3 will be gone. So my scale factor between these two solids is 6/7. That's the scale factor. Don't forget to answer the question. What is the question? What is the ratio of the surface areas? So the surface area of A to the surface area of B will be 6 squared to 7 squared, which will be 36/49. There you go. Write your summary, and our next lesson will be on changing dimensions.